Welcome back to the Internet Report's Pulse Update, the bi-weekly podcast where we keep our finger on the pulse of how the internet is holding up week over week. On this show, we're talking tax day and how IT teams can navigate major spikes in demand, whether it's tax season, Black Friday, or another high traffic period, all with the goal of giving customers the best possible digital experience. We'll also chat about the latest outage trends and cover recent outages at Apple, WhatsApp and Square, among others. I'm Barry Collins and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to like and subscribe. And for all our YouTube listeners, don't forget that we also release this show on all the major podcast platforms, so feel free to follow us over at Spotify, Apple Podcasts, or wherever you like to listen. So on with the show, and I started by asking Mike what companies should keep in mind as they gear up for a major influx of traffic during periods such as tax day.
There's a couple of things we need to consider here. So we're talking about tax day. We're talking about a specific day of the year and everybody's going to jump on it. So this could be something in the lines of like a Black Friday or a major sporting event. What it is this one-time event. So there's a couple of things here. Obviously, you can scale up for that specific day. So you can say, as the provider itself, this is what we're going to do. We know we're going to have this influx of people. And you can design to that and you can have elastic databases, as it were, so you can actually get that connectivity coming in. So if I flip that back to when I'm actually doing that for an overall scheme of things, I'm not going to design my infrastructure to cope with this load specifically the whole year, but I need to cope it for here. The other aspect to that we should consider is what's happening on these days when this is occurring is targeted. It's known this is the days around there. So you're also then open to all these potential other things coming in. So maybe a phishing attack. We've seen it where people believe because of load, there's some sort of DDoS attack going on to these systems there. The point is it becomes a focused event around there. So there's this increased vigilance from a user point of view. You need to understand what's going on and even then understand the paths my traffic's taking there. So again, we're talking specifically here about the tax, but let's consider it something else. Let's say the Black Friday sale or the census, when you have the census types of things. We have all this data flowing over there. Data is incredibly rich, incredibly powerful, and we know we've got to deliver it at that moment in time, in this case, our tax information. So how can we actually make sure we're taking the path we expect to take?
Can you give us an example of a time where things didn't go quite as planned on tax day, Mike?
There's several types of things we can actually see. And if we go back to 2018, the IRS website experienced an issue where at major tax time, they were directing last minute filers to come back on December 31st, 99.99, instead of where they should have come back in the 2019 or later on in that year, December 2018. I think it should have come back at that point there. So although an extension was granted to them, they weren't actually granting them an extension of 7,981 years. So in this case, there was some sort of mix up in terms of the filtering. But equally, we can have these situations where we have the load. We have a situation in Australia where during the census, because all the people were supposed to enter the information at one particular time, we had this situation where it overloaded that server. So you have these two aspects that can occur there. You can have a load one and you can have configuration. Now, the problem with the configuration is with all the best will in the world, there's only a certain amount of testing you can do, and it only takes one slip up to do that. So, we put in there and it's just somebody actually either failing to fill in a figure or putting in the wrong figure there. And then it sort of impacts everything down, which comes back to when we talk about this service delivery chain and all these components connected together.
In the UK, this used to be one of those annual news stories where every year the government's tax website collapsed under the weight of demand on deadline day, but it appears to happen less frequently in recent years. Has the move to cloud computing and being able to spin up extra capacity at times of peak demand helped with these situations?
It's an excellent point. Yeah, absolutely. We've had this, and I think we talked in the last podcast about this concept of the user requirements driving the technology and the fact then we're seeing this around cloud. Now, the beauty of cloud and to a large degree is what we're seeing within the network space now. We're talking about software-defined networking. We have this flexibility, this elasticity, as it were, so we can actually sort of stretch that so it can spin it up on demand. But if we go back in time, we had fixed service. We were looking at a bricks and mortar data center. So do we have to buy infrastructure? And realistically, we're talking about one day a year or a week a year. So we don't want to scale it up. But now we have the capability to remotely and through software define and spin up. And you can even, it's going to be an automated orchestration. When I reach so much load across here, when there's so many users coming in, what you do is you actually spin up another instance from here. And then you can do this sort of quite easily. Like I say, the whole process can be automated. So it's actually really cool. Now, what this then does essentially is it starts to move your bottleneck somewhere else. So we might then move the bottleneck into the internet where you're at the behest of the providers themselves. And it's this pint into a quart pot or quart into a pint pot. I always get those around the wrong way. But basically, sort of overloading too much sort of data coming through. And your path is only as big as your sort of smallest pipe. So if you happen to be coming across a bit of wet string, that's the bit that's going to bottleneck it. So it's looking at that, everything in context. Or you could even flow back in. It comes right back into your home location. So again, we're entering this stuff. We've gone to this technology now where we can enter, and we're talking about tax. We can do our tax returns either through a bureau or you can actually do it online. And therefore, then you might be at the behest of your own environment. Is somebody else on the Wi-Fi at that moment in time? Is there some sort of issue in the local environment that's impacting your connectivity? So again, understanding where that is, you can then start to take steps to sort of move around it. I've kind of moved across from this flexibility, but it all comes into this dynamic environment, this distributed architecture, and being able to cope, and it's sort of suiting the users as well as this infrastructure in the back end.
Now we move on to examining specific outages over the past fortnight. A range of Apple services suffered disruption on April the 3rd. Over to Mike to explain what went wrong.
First thing to actually say across here, this impacted only some users, right? And as I mentioned that is because that's quite indicative to sort of what we had. And I want to talk about the signals that we saw coming as a result of this issue. So absolutely correct. It impacted a number of services. It impacted things like Apple Music and the App Store. Now, how it manifested itself is you could actually get onto these pages. You could, if you, for all intents and purposes, you could load the page. It looked like the applications were there. But then if you wanted to actually get more information about it, so like you have the more page where you want to pull it down, so there's many updates, or you update or install that was when it actually failed. And you were getting sort of errors coming back from there, service unavailable, or it's just not connecting. And then we saw, in fact, some of our own users, some of our own 1,000 Eyes employees had this situation where they were looking at the music, Apple Music, and it was just spinning. It was unable to connect, so they couldn't pull any information down when this issue was occurring there. Now, again, coming back to this thing that I'm talking about, the signals, it was some users. And again, if you think about the context of the Apple Store, each Apple Store is regional. But then this is essentially going to impact some of the applications in the back end. So which applications are available from that particular store? There's no point, for example, having some of the banking apps from a US perspective available on the Australian store, or on the APJC store. It doesn't make any sense to do that, or from a local language point of view. So it had a global impact. In fact, it impacted all the regions we saw come from there, but it was only impacting some users and accessing some of these services.
Perhaps the first thing that Apple would have noticed during this incident is a reduction in page load times of visitors, which most people would assume is a good thing. But this shows the importance of thoroughly checking any unexpected change to your service delivery, good or bad, right?
The way that Apple would have been looking at their services, they might not say be looking at page load time, because in a sense, it doesn't mean to them. They want to do the complete transaction. But that's still a very important signal. Let's flip that back. Normally, if I see a reduction in page load time, and what we're talking about from page load time is we're talking about the time it takes to load a website page. So that includes a number of components, back-end objects, and whatever it is makes up that page there. So that's what we talk about page load time. The time that page to completely render, first to last byte. Now, if we're talking about that reduction time, it implies it's got faster. So therefore, it's actually loading quicker. So that's really good. But then if I take that signal and I suddenly then look to say, well, how many objects are on that page? So we talked about a page load having to render all these objects or call these objects in from there. If that number's dropped down, then quite clearly, I'm not pulling down all the information that's required. Now, some of those objects might be static, so loading a brand or a logo from there, and then some of the information is dynamic, some of it's prefetched, where I'm actually going to go to a cache and sort of pull that information down to there, and some of it is on demand, which is where I want to then pull that back end. So again, looking at those two things in those two signals, I'm saying, right, page load time's reduced. I'm not calling that good or bad at this moment in time. has the number of objects decreased or increased? It's decreased, and what we're normally expecting, okay, I can actually now suspect I'm actually not loading that full page, so therefore that isn't a good thing. Now, I go one further than that. Let me look at the next signal. Do I have connectivity? Do I have connectivity into that application so I'm able to authenticate to it, for example? Because connectivity to the front door could mean I'm just going to a CDN. So I'm just going to a cache type of environment there. So I'm looking at all these signals combined, and then for there, you can then sort of deduce, all right, we're now looking at something with the back end because I'm not pulling the information. What it looks like I'm getting is static or cached information. So it's this dynamic information I need, which is in the context of calling down new records or calling down applications or updates to the applications. That's where I'm going there. So straight away, by looking at those three signals, I'm able to say I'm looking for something in the back end.
So in this case, we saw disruption to services that meant people couldn't download music or update applications from the App Store. And these were obviously serious disruptions, but there didn't appear to be any secondary consequences. Is that a fair assumption?
That's a fair assumption, and it's actually a really good point to make if we consider that then from the holistic stuff. So in this case, absolutely right. We had this impact. We couldn't retrieve this information. What you saw on the label is what you got. I couldn't pull that information down. And obviously, it's serious. If I need to get that music, if I'm a developer trying to update that. But coming back to this point where we talk about multiple signals and looking at signals across there, imagine if this was up into the authentication stack. Now, there is some sites that use other third-party authentication systems. So use your credentials for X, Y, or Z to log on to my system. Now, that is this disconnected consequence or this secondary consequence, as you put it, that has this impact sort of downstream to it. So if I'm looking at that from one signal, what I'm actually looking at is I'm saying, oh, I can't log on, therefore there's a problem with system X, wherein really it's this other system downstream that has the problem.
So it's not just about looking at a single signal and trying to work from there. You've got to look right across the board at multiple signals to work out where your problems are coming from.
Yeah, absolutely. And always in context. So, what is the process it's actually doing? So we talked about the fact then that we're doing the authentication. It could be something external to that system. There's a big storm happening in this particular area here. The example I always use on this is, and it's going back a few years, but when they had the Large Hadron Collider in Switzerland, they also have actually a smaller one, and it actually runs under Lake Geneva coming around, and they had problems with the some of their data was coming out from there, and they couldn't work out what was going on. Well, they actually looked around, and then they found out, and they correlated this together, that it exactly correlated with the time the trains were leaving the station at Geneva Station and where they run across there. And because of some of the sort of the interference across the water and across the lake, it was having just enough period to put it out from there. So again, it's a wacky example off to one side, but it kind of illustrates the point. We have this signal over here, which is the train timetable that coincides with this point here. If I'm just looking at why I've got deflection, I can't understand it. But put that down with the train timetable, it exactly happens at the same time. Come back again, look at the authentication process. I've got an authentication process here, and I use systems X authentication to allow people to connect into my system. And it could even be the signal is that all of a sudden people aren't getting on and they're re-registering for their accounts. So I see a peak in traffic of people registering. So again, it's always looking at these signals. You can't ever look at one signal on its own because it would potentially lead you down the wrong path.
Now we're going to round up a series of other incidents Mike has observed over the past fortnight. Let's start with Meta.
So this was also on April the 3rd, so the same day as we saw the Apple outages, a little bit earlier in the day. So there's some Meta services, most notably WhatsApp, and to a lesser extent some of the other services such as Messenger. Now again, these experience global disruptions. Similar to what we saw when we talk about Apple, and I'll get into similarities a little bit there, was that you could actually get onto the application, you could load it, there was information there as well. And some people even could actually send messages or attempt to send messages, I should actually say. So you could actually create a message and look like you're sending it, but that message then wouldn't send. So coming back to our first point, talk about these signals, straight away we're saying, okay, we can get to the application. It indicates our network's up, indicates we can actually get to the system. Looks like a problem where we're actually sort of pulling stuff from the back end. So again, we have these, we know we can get to the front end servers, the paths appear well. It's when we start to go into the back. Now, Meta actually confirmed this later on that it was actually a problem with the APIs. It actually looking for this system connects to the APIs. And that kind of confirmed what we saw. So it actually appeared, again, we talked about this system where we're connecting to WhatsApp, Messenger, and Instagram. So these were what we're going to call functional failures. And that, what I mean by that is that the application is up. It appears to be up by network connectivity, so it's reachable, and you can actually do that. But some of the functions, you can make an argument that some of the main functions in this case were unavailable. So therefore, it was a functional failure.
Payment provider Square has also had some problems, Mike.
So April the 1st, Square experienced this service disruption. It impacting payments running on Android and Square hardware themselves. So Square is this payment process system that operates in restaurants and sole traders who have the little Square, funnily enough, that plugs in or connects by Bluetooth into the phone and actually allows them to transact. So again, we talked about this in the previous podcast, having this ability to outsource some of your functions, which allows you to operate as if you're a bigger one there. Now, what this turned out to be was Square came out and said that they had a new feature configuration and it resulted in some malformed JSON information, which is sent to the application itself. This is a configuration change that has an impact to how the application functions. So when we're talking about the configuration, again, I'm very old. We're not talking about one series of long code. We actually have sort of modules coming into each part of that. And the configuration, and even talking about APIs, we were talking about in the previous outages there, sort of they're making individual calls to different programs. We're talking about these different architectures, the microservices and sort of service architecture there. So I can actually make a change to that. And each hardware or each network is going to respond differently to that. Now, in some cases there, because this malformed JSON configuration that sort of came out of it, some of them were just rejecting it and then taking the latest response codes. But then what we saw was, or what was reported was applications running Android or on the Square hardware itself, they actually started a crash report. So it actually went down. So these two different systems. So again, we take that back to a broader system and we're talking about this from a network point of view. The way the application's characteristics and all the various components of its distributed paths are going to behave differently across different parts of the network or different characteristics. And what you need to do is be able to see the combination of how does the application interact with the network to the user at this location, as well as vice versa. How's the network interacting with the application itself? Now, in this case, like I said, we had the traffic was able to pass through, and it was just how this hardware then reacted to it. So we got to the system, and what they did find was in some of the way the configuration changed, that if you left it logged on, you could still function. It's when you came down that they were seeing this crash and had to relaunch the application going through.
The discovery of the XZ vulnerability was a very unusual case.
So the XZ one was very interesting. For those who don't know, XZ is a compression tool and it's used in nearly every Linux distribution. How this was actually identified is the key point to us. So without getting into the details of what this vulnerability is and how it manifested itself, what is really cool from our point of view is that this was identified by a particular maintainer of a SQL system who, when was looking at his system, he found that the system was actually running slowly. They had a performance lag. It was in the region reported somewhere in 600 milliseconds, I believe, this performance lag. And he also experienced this high CPU utilization when is it looking at a particular process going on. This comes back to when we talk about these different signals. He identified that this is something atypical to my environment. I normally expect this system with this configuration running these queries to perform at this when I'm actually making a query to it. And the fact that it was actually slow was these signals he looked at. But he had two signals he's looking at. So or three signals, I should say. I'm looking at what is my normal behavior, right? So this is what I expect to be. What is the performance I'm getting now? Was the variance in that? But then also, what's the compute infrastructure doing? So it looked like there was something else running on that system. And because of this anomalous behavior that he saw on the system itself, allowed them then to start to go in. And this is then when they uncovered this, which was sort of buried quite deep from what I understand in the system itself.
So the thing to note here, Mike, is that by having that good visibility over the network, it's helped identify a security issue, not just a performance problem.
Absolutely. Now, let's be clear about this. When we're looking at this, we are looking at the performance. We're looking at the digital experience. So what is the digital experience across that entire holistic chain? And this was kind of interesting in a couple of ways. So this wasn't, if you like, a traditional attack. So this wasn't a hijack. This went over a long period of time. And it was very much a social engineering exercise where the perpetrator embedded themselves into a development process. And they were adding and contributing to the code, which would allow them to put the backdoor in there. So there's probably not a security tool that's going to find that itself. And again, reiterate or re-stress that we're not looking at this from a security point of view. But the fact then that this behavior was different to us, as you pointed out there, allowed us to identify, well, what's wrong here? And then again, if we go through our signals, we're saying there's nothing wrong with the network and our paths are all good coming into here. We're looking at multiple Linux distros. So we're looking at a common potential degradation across all these environments that would see that. So the common point here was in this system itself, and it's also on these processes. So now we've narrowed it down to a particular area there. And again, that allowed it. So we haven't, in a sense, identified a security breach, or we haven't identified this vulnerability has been placed on there. But what we've had to say is that there's something off here, and this is a fault domain. This is where you need to start to look. And then you can look in there and it narrows it down. So straight away, you've reduced that time to be able to identify where the problem is or where we're looking from there. And again, it may have been gone and found out, oh, this is really just an inefficient query. Right, it's just someone's logging in, or it could have even been someone's coming into it from a different area there, and they're taking a different path. But by combining these signals together and looking at it in holistically, you're able then to say, right, this is where we need to look, and then put the specific people looking at that, and then they can do their magic and identify where the actual issue is.
Moving on, Panera Bread suffered a recent problem that forced it to take its service offline for a period.
US restaurant chain Panera Bread, they recently experienced, I think it was like a week-long outage. So this started on March 22nd, and according to the reports, it impacted its internal systems, its phones, its point of sales, its website, and its mobile app. So all these systems. Now, there's been no official confirmation, but if they actually look and they took all these systems offline, then it appeared there was some related to some sort of cyber attack that went on. So again, from our past patterns, we've seen this, we've reported and we talked about this in the podcast. I actually think this is an excellent way that happens. Obviously, something goes in, you have a cyber attack. What we need to do, first of all, is become an island. The only network that's not able to be infiltrated is one that's completely disconnected. So they took these systems offline while they're able to sort of go through, or this is what it appears to have actually done when they actually re-imaged or cleansed or checked or cleaned or identified this system there. So what they did in this meantime, again, we've talked about this in previous, is they went back to, they didn't cease operations. They need to be able to transact, but they actually went back to different processes. They already had this in place that in the event that they lost their systems for whatever reason, they could implement these manual processes in place to sort of how they operated. And I believe they started to bring things back online from there. So this is a couple of things. Again, coming back to our signals, if we look at this, then the signals is that we have no network connectivity. Lights on, lights off to these systems. We can't actually make connection to there. So that indicates something's wrong with those source systems themselves. And the fact it was this clean break and across multiple systems, again, is indicative of they've effectively taken things offline. So it looked a manual shutdown or a graceful close while they've actually gone through that process.
And finally in this roundup, Ray AI experienced a recent incident.
So this is an interesting one, and it's a widely used open source framework, mainly used in AI workloads. And what appeared to happen was there was this vulnerability that's been uncovered within the API itself. So how this is actually used and called within the systems. Without going into details of what this vulnerability is, what it actually allows us to sort of talk about here is this concept that the way the API is actually called is we actually need to have some sort of authentication or some sort of trust. Typically within this environment, they would not necessarily be exposed to the outside world. But what's happened is the way this has manifested itself, it means that these APIs have been exposed, which exposes the back end of compute resources. So effectively, these AI workloads have been able to be accessed and got the information out from those. These are huge sources of data. So this is essentially why they've looked and they've potentially sort of targeted there. Now, from our perspective, I'm looking from a signal point of view, what we actually be looking for, and again, we're not looking at the vulnerabilities on the system itself. I'm looking at the ability to be able to connect into them. So can I see this API from the outside? Am I making a call to that system? So I could actually have a test looking at this API and hitting it. And I'd expect to have some sort of attribution coming back to me to say either it's not there, so I'm not actually seeing it, or I'm actually getting some sort of error coming back saying you're not authorized to that. Now, again, then looking at some of my paths. So I'm actually then looking at my paths coming into where my workloads are. We can then start to see, has some sort of actual malicious intent gone on? So I'm looking at these signals and what they mean in terms of that environment.
Before we leave you, there's just time to take a deep dive into the global outage numbers. What are those outage trend lines looking like, Mike?
If we look at these global outages, they've been decreasing steadily since early March. Now, this is a trend we've sort of seen year over year. And we talked about this in the past. As we come out of the start of the year, we get this rise and then we start to drop down as we sort of come into there. The last week of March sort of followed that. And then as we now enter into April, what we then started to see was a slight increase. So initially we saw a 28% drop, and then we've actually increased by 23%. Now, this is reflected, or the similar patterns we saw in the US or US-centric outages there. The difference being is that initial decrease was quite slight, but the numbers were fairly low anyway. So we experienced a sort of a 2% decrease there. But then again, as we came into the first week of April, we saw this 21% increase. Now, the other thing about that then was between March 25th and April the 7th, 48% of the observed outages were US-centric. That means that the interface that was exhibiting the outage conditions was based in the US. Now, this represents sort of a return to this trend we saw certainly over 2023, and we're starting to see sort of evolve into 2024, where at least 40% of these outages are US-centric. Why is that important, and why I say we saw this previously? If we go back sort of pre-2023, what we'd see was an average over the year was less than 40%.
Previously, when the US outages were less than 40%, Mike observed that outages that emanated in the US spread beyond the States.
So for every outage I saw in the US, it had some sort of domino effect in another part or another region. So therefore the numbers went up together. That sort of kept that overall number down. But now they're when I see them, they're sort of fairly self-contained. Now this could be a representation of some sort of traffic engineering, could be the influence of software-defined networking, where they're understanding essentially what their potential blast radius is when they're making these changes. So when we talk about an outage, we're talking about the potential for it to be maintenance work. And when I talk about that, I'm talking about it at the time of day. We've mentioned this before, the time of day they occur and also the duration. And you can sort of see some of these automated recoveries coming back. So this is what we mean when we take it down, and then it impacts a different part of the world.
So the fact that the US outages look high is in some ways a good thing? It means there are less knock-on effects around the rest of the world?
The internet is resilient itself, right? So we can route around things, we can do that. But if I start to have these impacts where I'm making a change and it's having a change sort of in my part of the world during my business hours, it's more likely to have some user impact. So the fact then I can actually contain those, or I have a better understanding of, say, my blast radius that's going to occur, absolutely, that's a good thing.
That's our show. Please like and subscribe. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on X at @thousandeyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, from Mike and me, goodbye.